Welcome to our today's class. Today we are going to learn about rotational dynamics. So first of all, don't look into that book. I want you all to imagine something for me. You go out into the atmosphere and you look back on planet Earth. A blue planet adrift in space. Well, what do you see? You see the solar system, you see a sun, and there are planets, there are orbits, and there are multiple planets as such. Now, what do we have here? Our solar system. Okay, fine. Now let's come back to planet Earth. Since we started EVS back in the 4th grade, what has been taught to us? The Earth has an axis of rotation and also it revolves around it. But we do have that Earth rotates around the sun. So there you get it, rotational dynamics. Now come back down to you and me. Let's go down more. Let's dive deeper. What we see? We see bones, we see vitamins, minerals, lipids, fats. Let's go down more. And when we microscope to the tiniest building blocks of life, what do we get? We get atoms, we get neutrons, protons, and we also get electrons. But wait, we have seen that somewhere before. That's the orbit. So, okay, building blocks of life, atoms, they follow rotational dynamics. Also, the universe follows rotational dynamics. Thus, it is a very important concept to study rotational dynamics. So first, let's start with the most basic concept. It's uniform circular motion, UCM. Suppose I have a horizontal curved track and I go with constant velocity in constant time. So I will perform UCM, uniform circular motion. When we dive deeper into uniform circular motion, what we get is a concept, centripetal force. Now what is centripetal force? You may say centripetal force is this, centripetal force is that. Well, I'll tell you. CPF is just a word. It is a word. And what are words made up of? Letters. Okay, words have antonyms. So the antonym for CPF being CFF. So there are two forces at play here while performing UCM. What are those? First up, say you are sitting in a bus, right? And the driver takes a right turn. Well, okay, so the driver is performing UCM only for some amount of a time, only for that arc of a circle where he is performing a turn. So he performs UCM, and that's why centripetal force becomes the cause of UCM. Now, what is cause again here? Cause is a word. Words have antonyms. So CFF is the effect of UCM. So there you have it. CPF is the cause of UCM, whereas CFF is the effect of UCM. Now again, if it is the cause, means it's getting created by something, right? And if it's getting created, it should follow the Newtonian laws of motion. And that's why CPF, it follows the Newton's laws of motion. Whereas again, CFF, it does not follow Newton's laws of motion. Now, what do we have here next? Well, if something follows Newton's laws of motion, well then it should happen in inertial frame of reference. And that is why our next point is it happens in inertial frame of reference. And obviously, if this happens in inertial frame of reference, this should not. Okay, there you have it. A nice little diagram showing us the difference between CPF and CFF. We can also write pretty formulas for them right here. Here omega is the angular velocity, and we can write a formula for CPF like mv square by r is equal to minus mr omega square. And for CFF, it can be minus mr omega square. Now we put a minus sign to CPF, but most of the times we just don't use it. So also now we can see in CFF that it does not follow Newton's laws of motion. It is not performing an inertial frame of reference. So this becomes a pseudo force. It is a false force. So then if this is a false force, this becomes the real force. And if this is a real force, then we get applications out of it. And that is why our next point will be the applications of centripetal force. So the first application, it is the well of death. So you can have a diagram here. It's a cylindrical well, and then you see the circus part, right? In those drivers driving around in pretty huge circles. So let's understand it with the example. Here I am standing and I'm holding my friend and I'm telling him, come on, let's go out to play. And here is my friend and he tells me that no, I want to go study. So I apply a pressure of So I do 5 Newton work on him, whereas he does 5 Newton work on me. So we are cancelling each other out. But all of a sudden, his mom calls him and he's like, bro, let me go. And he applies 6 Newtons of force to let go of me. And at that time, he cancels me out and I fall face flat on the ground. And that is what happens with well of the death here. So the rider here has to maintain a minimum amount of speed with which he will traverse so that he does not fall here on the ground. And the formula for that speed limit is given with this. So not going into derivations today because of the time limit, but we have the formula V minimum is equal to Rg upon mu s. So this is the minimum speed limit. With this we can derive with what speed a rider should be going in the well of death so that he maintains a perfect speed such that he does not fall back to the ground. And as you can see, the rider is going in horizontal circles, so CPF should act upon him, right? So there are two applications. This was the first one. What is the second application? It is vehicle along a horizontal road. So as we can see here, there is a vehicle and it is going along a horizontal curved road. Now, as before, minimum. What is minimum? It is a word. So we have an opposite of minimum, V max, which is root Rg mu s. Now, what happens here is we can't alone depend on frictional force for the balance of the car, because the tire, they don't have enough friction, they don't have enough traction to generate, and that is why there is a risk of slipping or skidding the car, and that is why a maximum speed limit is generated. You go on a car drive and all of a sudden you see a board, there's 60 written on it. What is that? That is a speed limit, and that is the maximum speed limit that you should go while on that road, and that is derived by this formula. So that were the two examples of CPF in your real life. Now there is another example. So that was some part of rotational motion. It is very big chapter in 15 minutes, and that will be my session with you today. Thank you.